Hello and welcome back to openheatloss.com and my instruction videos on how to complete your very own heat loss calculation and system design using OpenHeatLoss. Now we're on to the first real biggie of what it takes to put in or create a good heat loss calculation and system design. How big this becomes really does depend on the complexity of the building and the number of different kind of elements that you've got. So for example, if you're living in a house that was built in the 1700s and has had 15 different extensions built over the years, and some very recently, plus you've had a series of window upgrades and all of that kind of stuff, you might be here for some time putting in U values. However, it does come across as a bit tedious, but it really is the foundation of your whole heat loss calculation. And if you get this wrong, your heat loss calculation could be out by miles. So it really does pay to put your time into doing this correctly. Now, you do need to do a bit of research on your house for this, so that you are going to have to do a bit of physical investigation to do things like measure the thickness of your walls, have a little bit of a kind of Google around to understand what type of build-up your house has got, just to really give it an understanding. Similar thing with the windows is what kind of windows do you have? Do you have single glazed windows? Do you have double glazed windows? How new are they? Those sorts of things. Good estimates are really helpful. So as we do this video, it will take us some time, and I'm going to go through it fairly carefully and fairly robustly, so that you get a really good understanding of actually what does this really take to do to do this properly. But what I am going to do is I'm going to make up a fairly simple house that has not had loads and loads of work done to it with various different U values, because I'm just going to give you an illustration of what it takes and how to go about it. Okay, so we're going to start off with a little overview to give you a map and some familiarity with the U value screen. So right here at the top, you simply have a very easy input to create a library of different construction types, and you can add a U value manually here. So if I tick this, it opens up with a category, a construction name, a U value, and some notes if you want to add notes for that particular thing. Now, your categories, you have external walls, internal walls, party walls. So party walls are unfortunately not anything to do with going to a rave or anything. They are simply a wall between you and a neighbour if you live in a semi-detached house or a terraced house, for example. You've got your windows, you've got your door, you've got ceilings. Now, ceilings can be external ceilings or they can be internal ceilings. So we'll go through the differentiation of that later on as we go through and build up this library. We have roofs. So the validity there is if you have a pitched roof where you have insulation inside it, but it's not actually the ceiling. Okay, or that you have a roof that makes up the ceiling. Let's say you've got an upstairs floor with a vaulted roof, that the insulation is in between your plasterboard ceiling and the external roof, or it's a flat roof, for example. So again, we're going to play around with how to categorize these things so that it makes sense for you. Then we've got floor. Now this floor is simply to do with intermediate floors. So they would be internal to the house, and they are in between your first on your second floor, or your ground floor on your first floor. So they are intermediate floors. They do not face the outside of the house or the exterior of your house. So your ground floor slab or your ground floor suspended are the floors that face the outside. So they're like your external, the equivalent of your external wall. Okay. And you'll see why this is so important in a little while. But these are really your categories. Now, if you're lucky enough, you might actually have a list of U values. So, you know, let's say you're in a newish house, or you're doing a self-build, or you're doing a retrofit where you're designing additional insulation. You might be lucky enough to know the values off the top of your head. You know, you might actually even have the U values provided from another heat loss calculation that somebody has created for you and that you trust, and you think they are fairly consistent. So if you're lucky enough to have that, this becomes a little bit simpler, because, you know, let's say I know I've got a wall with, you know, I'm gonna say that this is a house that's had some upgrades, and we have put in, somebody's had cavity wall insulation sprayed in, and it's fairly thick, because we know that there's a decent cavity wall, and we're just going to put this to 0.21. That is the value that we know this external wall comes to. So what I'm going to do here is I'm going to put my construction name, because new construction type isn't particularly helpful. So I'm going to put a construction name in here. So all I'm going to do is I'm going to do main house walls, just so I know when I select it later on when we build up the rooms. So that's now been added. Simple as. So that's the really basic version. Okay. Now I'm going to just delete this for now, because I'm going to then go to the next option that you've got to input these. Now, don't forget, if you want to add a U value, you can also go online and Google U values and put them straight in as well. However, this section here is RDSAP 10 Construction Library. Now, the UK's Building Research Establishment, they publish SAP details, which gives us some estimated standardized U values that they think are relevant for various different construction types by age band and by region. Now, you can use this tool. What I do say is that on some of these construction types, the values are really conservative, but on some of them, they're actually really spot on, particularly the latter ones, and actually have improved quite a bit over the years in terms of the values, actually, I have to say. So this Open Heat Loss uses RDSAP 10, and the recent values published back in June 2025, just for your reference. So it's fairly up to date in terms of what's available. There's nothing at the moment. We're in the beginning of 2026 at the moment, and there is nothing else, no updates to this at the moment. Now, what I recommend though is that if you have U values specified by an architect or by building drawings or any other references by a professional for your house, go by those. But otherwise, you can very much use this based upon a little bit of guesswork and a little bit of surveying of your own house, like measuring the wall thickness. Okay, so what's valid here? We want to select the element type we're looking for and the region. Now, this tool actually does an automatic lookup based on postcode. So obviously I have at the beginning of this project put in a Bristol postcode. It automatically brings up the region as England. And now I need to just select my element type. So we've got wall, roof, we've got exposed or semi-exposed floor, window or glazing, or an external door. Now, what we're going to do is we're going to look at the wall at the moment. Now, I'm going to say that this is a house that's on an estate that was built late 1960s, early 1970s. So not an uncommon at all build to have in the UK. So what I'm going to do is I'm just going to select my my age band to this period. And here you can see that it comes up with a whole big list of U values. And some of them are less valid than others, but some of them might actually be valid for some particular builds. But this tool just imports all of the data from RDSAP. So I'm going with what they're providing. So what we can do here is we can say, okay, so you know that you've got a cavity wall because you've done a little bit of investigation. And let's say, for example, that your wall is 300 millimeters deep, about a foot, 30 centimeters, which is not uncommon. So this is like you have like a cavity wall with block on the inside, brick on the outside, and about 100 millimeters in the middle, which is a cavity which hasn't been filled with anything. So there we go. We got an estimated U value of 1.5. Simple as you can now just go, you can leave this if you want to, but you know, it doesn't really matter. You can change the name if you want to. Again, you could just change this to main house walls, yeah, and then you just save it to the library. So if we scroll up, you can now see that I've got external wall, main house library, U value 1.5, and then my notes here are telling me exactly where I've got that data from. Now, if you're a heating engineer, that's really important, because if you have an audit and somebody is very particular and really wants to look at your designs and your heat loss calculations, you can say, well, this is my calculation, this is where I got it from. It's based upon industry standards, yeah. So that's just an audit backup type of thing. Now, again, this changes quite a lot if you have, for example, cavity fill insulation. So let's say somebody has come through the years and they have pumped in a load of cavity wall insulation, or maybe you were lucky enough that this house was built with insulation back in those days. So you can then put that instead and obviously save that. So that just gives you a bit of an example on the, you know, sort of like a standard cavity wall house. Now, if you've got an older building, let's say just for example here we have pre-1900s. So where I am, we get quite a lot of old buildings that have been built, and they have got big, thick stone walls. Now, a lot of them around me are sandstone or limestone. So what I have to do is I select that as a solid thick wall, and then what I do is I measure the thickness of this wall. So you know, around me it's not very uncommon to have things like 600 millimeter thick stone walls. So again, I'm just going to put this in here. I'm going to delete this bit about depends on thickness, because I kind of know that, and I'm going to save this one to my library, and that's obviously calculated my U value based upon thickness. So yeah, so if you have these solid walls, you can obviously kind of determine what materials you've got, because they do tend to depend on region. And you know, just do, you know, like I say, you got to do a little bit of research. Okay, now one note I am going to make here is when it comes to solid walls, these values on this are very conservative, and I found on a number of occasions that they do very much overestimate the amount of heat loss that that comes from these, or the amount of heat loss from these materials. So what I tend to do is that I will put these in when I put together a building and the building elements, is I will put these in from the standard RDSAP ratings, and I will run a calculation with those. But I will then also go to, there are a couple of places where you can go and get much better data, where in situ measurements have been completed in, you know, over a long period of time. So there is the Society for the Protection of Ancient Buildings, and there is also a reference document available from, I think it's Scotland Historic Buildings, and it's something like document 10. I will put a link in the bottom of the description of this video to those sources, so that you can actually go and research that yourself and adapt and modify the U values according to those in situ measurements, which are a very, very good basis for kind of designing for older properties, which also means that you're less likely to oversize your heat pump. So that's just a really important note there about these standard things. So so that's an example here of what you need to do. So select your element type. Your region's already filled in from your postcode. Find your age band. You can also put the build year in if you prefer to do that, but you just put in the age band and then select the type of construction that you've got. That should give you a pretty good starting point for all of this. So similarly, we have windows or glazing. So what you can do here is you can select your glazing type. You know, so many people now have double glazing, but you know, and lots of them are in the last 20-25 years. So there's quite a lot now who've had these upgrades to this kind of thing. So double glazing, frame type, PVC, wood or frame, or metal frame. So I'm just going to choose PVC here. And what I'm going to do is I'm going to say, okay, I've got double triple glazed PVC wood frame from 2002 2.0. So we know that there are older windows in this place, haven't been done for a while. That's okay. Now, the older figures that they used to use prior to 2025, the U values for these were pretty much higher. So at least they've come down a little bit. I have to say though, the double or triple glazed to 1.4 is actually a little bit low, I would say, as of 2022, because I think there are still a lot of manufacturers that will build these to a whole window U value of 1.6. So just be a little bit cautious about that. But you know, but obviously these are published figures and standards. So if you don't know your figures, you can use these and you have a legitimate backup for why you use these figures. All right. So what we've got here, we've got windows, double, triple glaze. I'm going to remove the solid wall. We've got our main external walls 1.5 because they're uninsulated. We have got double or triple glazed windows at a U value of 2. So what we're now going to do is we are going to input. So this is where you do have to have a little bit of again, guesswork here, because what this does is this tool pretty much looks at external elements rather than internal elements. However, you can still, for intermediate floors, for example, you've got an intermediate floor that goes between your upstairs and your downstairs, semi-exposed upper floor as built, insulation unknown, 1.2. That's okay. All right, that's an okay value to use because you don't quite know what's in there. But a lot of the newer buildings have got insulation also built into the floors, partly for noise, but also to help with insulation between different rooms. So again, that's a little bit of research that you need to do. I am going to build an internal floor and ceiling tool to be able to just put those in. That will be coming very shortly. So so at the moment we'll just scrabble around. We'll just use this value. But then what I'm going to do is I am going to, no, we're going to use this as our value. That's okay for now because I can show it to you. I just want to demonstrate how this all works. Okay, so we've got external wall, we've got a floor, and we've got a window. We probably ought to put a roof in there because otherwise we're not going to be kept very dry. And then here, what we have is we have pitched roof insulation at joists. So that's like if you go up into your loft and you have insulation that's lying on top of the ceiling, that's your insulation at joists. And then down here you have insulation at rafters. So that is that if you go up into your loft and the insulation is on the slope of the roof, in between the rafters, then this is what you put in here. So there will be a difference between these values and these thicknesses. Okay, so here we have, let's say you got 300 mil, it's 0.19 if it's between the rafters, and here it is 0.14 if it is between the joists. So it's actually better to have insulation on the flat than it is to have it on a slope. You've also here got you got room in roof, so you might have put in, so you might have had an extension and then you've got a loft conversion or something like that, and you've got let's say unknown insulation, assuming some older insulation there, 100 millimeters, or you've got flat roof as built insulation unknown. So you've got a few little options there. I know they're a bit limited, but that's why you've got to do a little bit of research when you do these U values. This is one of the reasons why, for example, people wonder why the design costs can be quite a bit when you do a proper heat loss and system design, because actually as a designer, if you're going to do it properly, you've got to do your research and you've got to find the figures, and so laziness and shortcuts does lead to poor design. So this is one of those reasons why it costs a bit of money to do the heat loss calculation. So we are going to say that we've got a nicely upgraded 300 millimeters of insulation at our joists. So that's going to be saved to library. So what have we got now? We've got external wall 1.5. We've got floors. That's our intermediate floors, by the way. So between upstairs and downstairs. We've got a roof and we've got our windows. So now we're going to need to add a door. So this is our external door. It's going, so is it going to an unheated corridor or stairwell? No, it's going to outside. And then we're going to do the, we know when we built the building, this was 1967 to 1975. And we have an uninsulated door there at 3.0 because it is just an old wooden door. So we're going to save that to our library. So now we've got window, we've got a door, and so forth. Now, what I normally do as well is, even though this is door to outside, if you've got wooden doors internally, you can pretty much guarantee that this is about the U value for that. So we all have internal doors, unless we've got a completely utterly open plan house. So I'm just going to put my internal door into there. I'm going to remove that. I don't really care about that. I just want to know that this is my internal door. So I'm going to save this to my library. Now, I am looking at my house. I've got my external door. I've got my internal doors. I've got an external wall. I've got my floors. I've got my roof. And I got my window. So now what I need to do is I actually going to think of this through. So what else do I need to make up and build a house? I have got, there we go. I've only got external walls. So now I need some partition walls. So again, like I said, I'm building up to providing a an internal construction, sort of reference manual on this, because this doesn't really give me the details that I need for an internal wall. These are all a little bit too high. But nevertheless, what we can do is we can say that these internal walls, I'm lucky enough that these were actually built with solid brick. I know that they're single brick, so all I'm going to do is put these in at 100 millimeters, and I'm just going to do solid brick partition walls. Yeah, so we're playing around with the figures using what we've got in here to the best of our abilities, and I'm going to just save that to the library. Okay, so I've got external door, internal door. I've got external walls, and I've got this one I've just put in. I'm going to change this to an internal wall so that my references are much better. I've got my intermediate floor, I've got my roof, and I've got my windows. Now, what I'm going to do as well here is that I'm going to say, oh yes, actually what we did do is we had some nice bifold windows added a few years ago. So from here, I'm now going to, I'm going to call this a window, but I'm actually going to do living room bifold. Living room bifold. And they were done pretty recently, so we know that they've got a U value of 1.6. And I can just do manufacturer specification. So I know that my I can just do manufacturer specification U value. So I know that that's the manufacturer specification for the bifolds that are going to that sit in the living room going out onto the patio. So here we go. So this is a fairly basic build up. Now the only thing I've got left to do here is I've got to go and do my floor U values. For these are for the externally facing floors. Now this one is actually quite a job, because the U value of floors actually depends on what we call the perimeter to area ratio. So we actually need to measure the room dimensions and understand what, how long, or the perimeter faces the external part of the house, as well as the external floor itself. So what I'm going to do here is just go through this, and I do recommend that you do this for every single ground floor room that you've got, because you'll find that the values actually change, and they can change quite significantly, and that has an impact on the heat loss of your house and the sizing of your heat pump, the sizing of emitters, and everything else. So do go through this. It might be a bit boring and tedious. You might have to get your head around it, but in my view, it's worth every little bit of the effort for what you get out at the end. Good bit of investment, I say. So now on this one, we now know that this is a slab on ground, and that's the first input. Obviously, if it's suspended timber floor, you put in a suspended timber floor. Or some houses are now built with a suspended concrete floor. So you just need to double check. These are probably newer buildings, let's say 10, 15 years probably. There will have been some earlier ones, but yeah, just double check if you're in a newer property what kind of floor you've got. But let's say for now we got slab on ground, and the options here then that you go through first are your floor dimensions. So it actually doesn't matter which way you put these dimensions in. The app will deal with this without any problem at all if you wanted to do a table lookup automatically. Now the limitation with the table lookout and the data that this comes from, which is essentially from the Chartered Institute of Building Service Engineers, is that the table only covers rooms with lengths of 3 meters to 10 meters on both of those. So if any of your measurements are outside that, don't use the lookup table, but we're going to go through that in a minute. But let's say I've got a nice, reasonably sized living room. So it's 5 meters wide, 8 meters long. Okay, so here's a bit of an explanation. Shorter floor dimension on A, longer on B, but the table sorts automatically whichever way you put it in. So just don't worry about it. Then what we need to do is we need to say how many exposed sides do we have. So I'm now going to put in, so this is actually the corner of the house. So I now know that I've got two adjacent sides, the back and the side corner of the house. So that's what I'm going to select. And now here you can see that it's done an automatic calculation of my perimeter to area ratio, 0.330. Now, you don't need to know the details of that. Now, what we then have is wall to slab thickness. Now, again, if you haven't built the house and you don't have any drawings, you don't know. This just comes up as a standard 300 millimeters because that is the typical type of thickness that we get with brick walls nowadays. Okay, but you can measure your brick walls and you can just put the value of that thickness in there. Now, the other side to this is that you often don't know your floor insulation thickness. But a little bit of research can tell you that in 1967 to 1975, it was pretty unlikely that you got any floor insulation in that slab. You might have been lucky, or you might have had some upgrades. Who knows? Do your research to find out. But here, you've now got your floor insulation thickness. So I'm just going to put this back down to 0. And just because we're going to assume that there is no insulation. But if there was insulation, we go back to the 100 mil, we can choose what type of insulation is in there. Now, usually what you would find in a solid slab on ground is either EPS, XPS, or PIR. You won't find mineral wool underneath slabs. You only find mineral wool under suspended timber floors, really. So here is so basically that's what you're going to get if you do your thing. Or, you know, this just calculates some standard rates, but you might have some different insulation. You might have had blown glass insulation because you're doing an upgrade to a cottage that was built in 1430, and they've dug out the whole of that floor and put in a load of blown glass insulation to allow the floor to continue breathing. So you might enter a different value, but don't worry too much about that for now, particularly if you don't have insulation. So we're going to put 0 on this one. We also know that we've got no edge insulation, basically, because the slab just goes straight up to the brickwork. And what we then have is it's calculated for us that we have a floor U value of 0.696. Now, obviously, up here it says it's below Part L 2021. Well, of course it would be, because it was built in 1967 to 1975, our example house. Yeah, but if you're doing something new, or you are building or you're doing a retrofit where there is a requirement for upgrades to pass Part L building regulations, you can use this calculator to ensure that you're getting there. Okay, so on this one, we're now saying, well, this one is the living room floor construction. So I'm going to save that to library. Okay, and now what I'm going to do is I'm going to just chuck in a curveball here, and I'm going to say that we have we've actually got we've done an open plan kitchen as well in this design. So it's huge. So we're going to say that one dimension is 10. We'll say that the other dimension is 8, because it's on the same side, you know, sort of symmetrical to the living room. And I'm going to say that this one actually has 3 sides exposed. And when we actually did the upgrades to this, we did dig out the floor and we put in 100 millimeters of EPS insulation. That's like polystyrene, it's expanded polystyrene. We put that in. So now, as you can see, it says that it meets Part L. It's come in at a U value of 0.235. And it's all good to go. But here we got the PA ratio. You can see that the other room, because of its dimensions, was different. It was 0.330. This time it's 0.350. So it's then given us a nice little insulation comparison on current dimensions as well to see where we're at. So if you were again modelling a retrofit or modelling something new, you could be looking at these figures and going, oh, actually, I'm going to put 200 millimeters in there because the marginal cost is virtually nothing. Yeah, so you can use this for design purposes of a house if you're a self-builder or doing a deep retrofit. So I'm now just going to put this in as kitchen floor, and then save that to library. Then what I'm going to do is we're just going to do some quick other rooms. Let's say we've got 3 by let's say 4 meters, and that one has got 2 sides exposed. Not 2 opposite sides, a corner, and we're going to say that this has got 0 insulation in it, and this one here is our dining room. So we'll just put this dining room there. So we've saved that to library. So we've now got our kitchen, living room, dining room. And we're going to say then that we've got a hallway as well, just to give you another example here. So on this one, the hallway is only 2 meters wide, so this isn't going to work. So what we're going to go here to is we're going to do a manual PA. And the hallway goes quite a long way through the house. We're going to say that's 6 meters. But we're going to say that the width is only 2 meters, and then we're going to say that we've only got one side exposed, which is where the front door is. And so what we then need to do here is this comes up with 0.5, so you've got to put this back to 0, so that this then calculates this value, the manual PA. Okay, and we're going to say we've still got no insulation. And look, here we go. This has given us a value of 0.427 on the floor U value. So now I'm just going to call this this is going to be the hallway floor construction. So there we go. So there's our there is our basic construction of our downstairs on this house. Now, do you want to put in another one? Let's say we've got a little odd L-shaped room that is just like a utility space and storeroom that we've got, and maybe downstairs cloakroom or something like that. What we can do there is that because it's a weird shape, it's actually an L shape, and we can't really just model this particularly well. What we can do here is we can do a PA manually. Now, what this does is, what you need to do then is, if you've got an L-shaped room, let's say you've got two long lengths. Let's say this is really long, and it's got like 12 meters long, and you've got you've then got another length that is let's say 4 meters. So we've got your 12 plus 4 meters, which is the this is now your exposed perimeter. And then what you do is you calculate your area. So let's say we've broken that up into 2 little rectangles. Let's say the room is 3 meters wide. We then have an area of 12 meters times 3, which is 36, and 4 times 3, which is 12. So we then have an area of 48. Okay, so we have then exposed perimeter divided by floor area. So we have our floor area, which is going to be 48 meters. Yeah, so we've got exposed perimeter 16 divided by 48. That equals 0.333. And there you go. You've calculated this manually. And that is just going to be utility floor done. So there we go. That's the floor U value entered in manually, calculated PA ratio. So this should now be in our U value catalogue or U value library, and there it is. So now we've got door, external wall. So we're going to just assume that the house has got the same external walls throughout to make our life easier. We've got the intermediate floor, we've got a ground floor slab in several places. So we've now got 5 of those to cover the various different rooms. Downstairs we've got a roof, we've got window, and we've got window. Okay, so now we're going to just add, for the sake of brevity, I'm just going to add a ceiling in there, and I'm just going to call it intermediate floor, intermediate ceiling. And on this one, technically speaking, the floor here, if you have a floor and a ceiling, when you fill in a room detail, and we'll cover this in more detail when we do the rooms, they're both one and the same. It's just that what happens is heat transfer upwards is greater than the heat transfer downwards. So what I'm going to do here actually, and I'm sorry if this causes a bit of confusion, but basically I'll put the ceiling as 1.2, and then what I'm going to do is put the floor at 0.9 to reflect that the floor in the intermediate, we'll do that again, rename this intermediate floor, just so it's a bit clearer when we do the whole room by room heat loss. So we'll put it as floor, intermediate ceiling, 1.2, 0.9. So that then gives you the option of obviously modelling this correctly in terms of heat flow through the house. So that, I'm hoping, gives you a fairly good understanding of creating your U value library, what it takes, the kind of detail that you've got to put into it, and the sort of timescales that it takes, especially when you're modeling floor U values, because as we've seen, the U values and the floor do vary by quite a lot, depending on various different inputs. So that has a very big impact on the overall thermal performance of the house. So that's that bit. We have now obviously done this part of the heat loss calculation. I'm hoping that was a helpful video, but like with all of the other ones, if you have any questions or comments, please do leave them below the video, and I will answer those as best as I can, or even just do a video if there's a pattern on questions that comes out of those. And I will look forward to seeing you in the next video, where we're going to start inputting the rooms for the house and start really building the heat loss model for this little project that we're doing now. So thank you very much, and I will see you in the next one.